we've got a cross number to try and figure out here. 4 clues, and we're trying to work out the answer to 2 down. Now, obviously, some of these clues we can't even begin to use. So twice the answer to 2 down, we need to have some information on 2 down first. 60% of 5 across, that's no good. A prime, which is the sum of two squares. There's going to be lots of possibilities here. So really, the starting point is to look at 1 down. P times Q, where P and Q are prime, Q is equal to P plus 4. So I'm interested in my prime numbers and 2 of them that differ by 4. But notice also that I'm quite restricted because I have a 2-digit number. So I'm going to write down my prime numbers: 2, 3, 5, 7, 11, 13, 17. And then I'm going to look at ones that differ by 4. So 2 doesn't go with anything. 3 and 7 go with something. So 3 times 7 is 21. So that's one possibility. Look at the 5. No, 7 and 11 also work. And then there's no other possibilities until I get to 13 and 17, and that's going to be more than two digits, so I can just ignore that. Okay, this is brilliant because I've narrowed it down to 2 possible answers. Now, if I put in 21, I could try them both out, couldn't I? Then here's the thing: 3 across says it's twice the answer to 2 down. Now, there's no way that I can have a 3-digit number that starts with 1 that is twice some other 3-digit number. So I'm going to reject the 21. And I've got my first answer, 77. Right, next we want a prime, which is the sum of 2 squares, but now we know it starts with a 7. So this is good news. And I can just try and find some things out. Now I know it starts with a 7, so if I have 1 squared, can I add 1 squared to something to be in the 70s? No, because the closest I can get is 8 squared, because that's 64. That'll give me 65. If I go to 9 squared, it'll be 80 something. So I'm not going to get anything from here. What about 2 squared? Again, I got a similar problem. 2 squared plus 8 squared is going to be the closest. That's going to give me 68. It's still not in the 70s. 3 squared. Okay, 3 squared plus 8 squared is going to be 64 plus 9. I'm going to get 73. That is an option because that is a prime number. If I do 3 squared plus 9 squared, it'll be too big. 4 squared. Now, 4 squared plus 8 squared, that would be 80. So that's going to be too big. And then 4 squared plus 7 squared would be too small. So I can't get anything from that. 5 squared plus 7 squared is going to be 25 plus 49. That's going to be 74. That's not a prime number. I can rule that one out. And then 6 squared plus 7 squared will be too big. But 6 squared plus 6 squared will be okay. 36 plus 36, 72. But no, that's not prime either. So I've exhausted all possibilities. You can see they're getting closer and closer together. And now I'd be swapping around and I'd be doing 7 squared plus 5 squared, which I've already dealt with. So it must be, this is good, that 1 across is equal to 73. Another clue sorted. Right, now this is where my solution and the official solutions are going to vary slightly. So the official solution, start looking at 60% of 5 across and using the fact that you must have a multiple of 5 going on somewhere. But I didn't go down that path, and I'm going to show you the way. It might be a bit more complicated, but I quite like it, so I'm just going to show you it. So now we're trying to find, right, 3 across is twice the answer to 2 down, but we don't know what either one is, so it doesn't particularly help. But why not introduce just some digits into there? Now I can write then 2 down, sorry, twice the answer to 2. So I can write 2 down, actually. It's going to be 3AC. I can write it as 300 plus 10A plus C. So writing it from digit form to, this form. I don't know what actually this is called. And then we know that, so sorry, 3 across is then twice that. So I have to times this by 2. So if I find twice this, then I'm going to get my answer to 3 across, which is 700 plus 10A plus B. And I can get some relationships going on between A, B, and C. First of all, multiply out 600 plus 20A plus 2C is equal to 700 plus 10A plus B. I'm going to minus 100 from both sides, and I'm going to minus 10A from both sides. So I'm going to get 10A plus 2C is equal to 100 plus B. Now this actually gives, even though we've got three unknowns in there, it actually tells us something because this thing here is necessarily greater than 100. And remember, A and C are just these single digit or these single numbers, one digit numbers. And so if A was, say, 5, then I'd get 50. The highest I could get would be if C is 9, then I'd be adding on 18. I'd get like 68. Now, if A is 8 even, then I'd get 80, and the highest I could get is 98. There's no way that I could get something that's greater than 100. So for this to be greater than 100, A has to equal 9. That's the only option. And I can put that into here. So we've just got this one other digit to find. Right, if A is 9, that changes things slightly. So now I can write that 2C, I can minus 90 from both sides. 2C is equal to 10 plus B. And I've got a relationship between these two. So I decided at this point to write some possibilities down for C and B. So for example, if C was equal to 5, then B would have to be 0, although we're told that they're all non-zero. So, and C can't equal 4 because then B would be negative. So C might be 6, and then we get 12, B would be 2. 7 and 4. 8, 6, 9, and 8. So I've got four different possibilities. I don't want to try all those out necessarily. I think the thing to do now is look at 60% of 5 across. So I'm going to now put another digit in here. So 5 across is going to be 10C plus D. Okay, and then we're told that the down one is 60% of that. So if I times by 6, if I times 5 across by 6 over 10, or equivalently 3 over 5, then I'm finding 60% of 5 across, and that is equal to 10B plus D. Now I know I've got another equation with another thing involved now, but let's just roll with it, see what happens. I can times through by 5, and I can times out the brackets. I'm going to get 30C plus 3D is equal to 50B plus 5D. Right, now I'm actually going to use my result from up here to try and eliminate one of them, because that might help, it might not. So I'm going to substitute in for B. B is actually going to be 2C minus 10. So 30C plus 3D is going to equal 50 times 2C minus 10 plus 5D. Actually, I probably should have minus 3D from both sides and made this 2D here. So 30C is going to be 100C minus 500 plus 2D. And then 70C is going to be 500 minus 2D. I've just rearranged it slightly. I've added 500 onto both sides, minus 2D from both sides, minus 30C. And therefore 35C is equal to 250 minus D. And I got myself another equation. Technically, this is called a Diophantine equation because it's got integer solutions. And let's see if that one yields anything, because this is really good. Because this number's big, there's going to not be very many possibilities for C. For example, if C is is 9, it's going to be too big because it's going to be 315. So let's try some things out. What about if c was a bit smaller than that? C is equal to 7. Then 35 times 7 is going to be 210 plus 35, it's going to be 245. And then what I would get that d is equal to 5. No, actually, that must be the solution. There's nothing else that it can be. If c was bigger than that, then I can't get a single digit for d, and the same for if c is smaller than that. So I've managed to figure it out. C is 7 and d is 5. And as the problem goes, we've actually done it. We found out what 2 down is. It's 397. Of course, just for completeness, I think it would be nice to find the value of b, which we could do quickly by just finding 60% of 75, but we actually already did it over here. We did the situation where c was 7. That was the one that is actually correct. And so we get b is equal to 4. So if you find, you can check this. You can see that if you double 397, you will get 794. So that one works. And if you find 60% of 5 across, 60% of 75 times by 3/5, you will get 45. Okay, good effort. Well done.